Welcome to the ZLearn Security video training lesson on how to interact with iDevices. In this video we are going to see some tools that can be used to interact with actual devices. We will see which tools need to be installed on the phone, as well as which tools are needed on our machine. Also know that most of the tools that we are going to see are available for different platforms, so the same steps can be performed on Windows and Linux. We have several ways to interact with a device. For example, we can use SSH, FTP, VNC, and many more. But we should note that many of these techniques are available only if the device is jailbroken. Let's start seeing how we can browse the device's files and folders. This is very useful to read and get files that may contain valuable information about the device itself, as well as installed applications. We are not going to use iTunes since it's quite limited if compared with other software. What we are going to use is software called iFunbox, which is available for both Mac and Windows. Since the tool uses the cable to communicate with the device, it must be attached to our machine. We have already installed iFunbox on our machine, so let's start it and see what it looks like and what operations it allows. Once iFunbox starts, we can see that it automatically recognizes the device. In the left pane is listed our iPhone. As we can see, there are many elements under the device node. We can browse user applications, system applications, photos, the file system, and much more. Let's start digging in the user application element. As we can see, here are listed all the applications that the user installed on the device. Right-clicking on each of them, we can perform further operations such as browse its contents, get the .ipa of the app, or even uninstall the application. Let's inspect the contents of this package by double-clicking on the app. This is the folder where the application binary and its files reside. Some of these folders contain user data, while some others, such as the .app package, contain the application itself. This package in particular is very useful if we want to perform reverse engineering analysis of the application. For now, let's focus on the other folders which may contain user data. For example, if we navigate in Library, then Caches, then Dropbox, we can see a list of files that have been uploaded by the user using the Dropbox application. In this case, we can see some PDFs as well as some pictures taken with the device camera. Since we may want to inspect these files, we need to download them onto our local machine. To do this, let's select the files or the folders we want and then click the top button, Copy to Mac. This copies all the selected files into our local machine. Let's copy them to our desktop folder. Now that the files are on our local machine, we can open the files and read their content. Here, for example, we can open the syllabus PDF by simply double-clicking it. The same for the camera uploads. Here we can see the preview of each image. As you can imagine, this may be very useful to get users' data from the device. Although these files may contain valuable information, there are other ways that applications store data. In most cases, applications use SQLite and plist files to store that data. So let's go back in iFunbox and see what we can find. In the preference folder, we have a few plist files. Let's download to our machine the file that has a size different from 0. When we open it, we can see some information related to the device, the user, and their preferences. Here, we can see the email address used by the user and much more. Almost every application has these files which contain user-related data. During our application analyses, it's a good practice to check them in order to find information that may be useful later on. Let's now see how to inspect SQLite files. Let's go back to the root application folder and enter the Documents folder. Here we can see two files with the extension SQLite. Let's download the Dropbox SQLite into our machine and start SQLite Manager from Firefox. This plugin is free and allows us to inspect the content of SQLite files. There are many free tools available online, so you can use the one that you prefer. Note also that we can use the SQLite command line to query the database as well. We will see an example of that later on in this video lesson. Let's click the folder icon in the top bar to open the Dropbox file just downloaded. Once we open the file, we can see its information by opening the tab labeled Browse Data. First, let's select one of the tables of the database from the right pane. Here we can see many rows. If we go to the end of the columns, we can see that there are entries related to the file stored in Dropbox. Here we see the paths of the files found before. Even if this database doesn't contain very useful data, there are many SQLite files in each application that have to be analyzed. So far, we have seen how to download and inspect files stored in the applications. But since the device is jailbroken, iFunbox allows us to inspect all of the content of the device. If we open the View Raw File System, we can navigate every folder and file stored in the device. For example, let's browse the folder where SMS messages are stored. So let's open var, mobile, library, SMS. Here we can see that we have some SQLite files. Let's download the folder into our local machine and load the files in SQLite Manager. Since the file extension is .db, we need to set the file format to all files, and then we can open it. Here we can see the tables stored in the database. Browsing them, we can see that there is very valuable information stored in it. Here in the chat table, we can see some information such as the senders of the messages. While if we open the messages table, we can see the actual messages themselves. As we've seen, thanks to tools such as iFunbox, much useful information can be gathered by browsing just the device. But as said at the beginning of the video, this isn't the only method that we have to interact with the device. Some of these methods may be useful to run commands directly on the phone, while others are useful to download and browse stored data, as well as use the phone remotely. We will see many of them during this video. Let's start by seeing how to obtain a shell on the device. A shell on the device is very useful for our testing purposes, since it allows us to run commands and tools on the device, check services, inspect files, dump portions of the memory, and much more. When we jailbreak a device, very few tools and applications are automatically installed, so we will need to tweak the device and add them. One of the most important packages that we have to install is OpenSSH. Also note that to use SSH, the device and the machine should share some kind of connection. For example, we can attach the device and the machine to the same Wi-Fi network, or use the cable connection to communicate. Since we need to install OpenSSH on the device, let's open a VNC connection to the device. This allows us to display the device screen directly on our Mac. We will see how to establish a VNC connection later on in this video. When we jailbreak a device, the application Cydia is automatically installed on it. This application allows us to find and install software packages on jailbroken devices. So let's see how to install OpenSSH. Let's start Cydia and scroll down until we reach this section, User Guides. Here, let's click on OpenSSH Access How To, and then click on the link OpenSSH. Now let's click Install and confirm in the top right corner and wait until the packages are installed. As we can see, all the packages have been installed successfully. We can now establish an SSH connection with the device. What we need is the IP address of the device. In this case, the device and the machine are attached to the same Wi-Fi network. So let's go into Settings, open Wi-Fi, then select the blue arrow on the right of the Wi-Fi where the device is attached. Here we can see the IP address associated to the device. We can now move on our machine and start a new terminal. In order to establish an SSH connection, we can run the following command: SSH, followed by the username, which is the default is root, then add the @ character, followed by the IP address of the device. Let's verify that the address is correct. Now the command is complete, and once we hit return, we can see that we are prompted to insert the password. If we didn't change any SSH configuration settings, the default password is Alpine. So let's enter Alpine and hit return. As we can see, we have successfully established an SSH connection. The shell that we are seeing now is a shell on the device, as we can see from the host name here. From here, we can run any command we want or browse any folder. For example, by running ID, we can print real and effective UIDs and GUIDs. We can see and display network connections by issuing netstack-an. If we go to the beginning of the output, we can see that there are some services in listening mode. Here, for example, we have port 22, which is SSH. Here's port 5900, which is VNC. We will see how to use VNC in a few minutes. Of course, depending on the tool installed on the device, we can run several commands. For example, by default, we can run SQLite. So let's try to query the SMS database that we have previously downloaded on our machine directly from this shell. Right now we are in the var root folder. So let's move into var mobile library SMS. Here we can see we have the same files as we saw before with iFunbox. Since SQLite is already installed on the device, let's run it against the SMSDB with the following command: SQLite 3 sms.db. Now we query the database from the SQLite command line. Let's get the tables with the command .table. Let's now run a select query against one of these tables. For example, let's get the values stored in chat. Select star from chat. As we can see, this is working fine. So with SSH, we have full access and control of the device. The shell is very important for our testing purpose because we will be able to run the commands and the tools on the device that will allow us to debug applications on runtime, dump encrypted portions of the applications from the memory, and much more. Let's now close this shell and move on. Since we have an SSH server running on the device, we can also use FTP through SSH. This may come in handy if we want to browse, download, or upload files to and from the device. To browse the device, we are going to use a free tool called CyberDuck. Once we have CyberDuck started, let's click Open Connection and select SFTP from the drop-down menu. Now, in the same way we did for SSH, let's insert the IP address of the device. In this case, the IP is 192.168.3.16. And then the username and the password used for SSH, root and Alpine. Now let's click Connect. After a few seconds, we can see that the view loads and we are browsing the device. Here, in the same way as the iFunbox tool, we can browse, download, or upload files. So this is another way that we have to interact with the remote device. The last method that we are going to use to interact with the device is VNC. During this video, we have already seen how it works. It gives us a view of the device that we can use to control remotely from our local machine. In order to run a VNC server on the device, we have to install an application called Vinci. To do this, let's go into our device, start Cydia, and open the Search tab. Here, let's search Vinci and then install it. In our example, we have already installed it. Once the tool is installed, we have to enable it on the device. So let's open the settings and scroll down until we find the Vinci app. Here we just need to enable it and choose a password for the connection. Now that everything is set on the device, let's close the VNC view we are using and let's start a new one. In order to establish the connection, we need a VNC client, which in our case is VNC Viewer. It can be downloaded at the following address. It is free and available for all operating systems. We already have it installed on our system, so let's start VNC Viewer and see how we can connect to the device. As we did for other tools, here we need to insert the IP address of the device and then click Connect. Now let's insert the password set on the device and click OK. As soon as we click OK, we can see that the device view loads in this window. From here, we can now interact with the device through our mouse and keyboard. We can lock or unlock the device, simulate the home button, and of course, simulate a click on the device. So we can do everything we usually do by using our physical device. Until now, we have seen how to connect to the device through our Wi-Fi. Sometimes it may result in slow connection, especially when we use VNC. To escape this problem, let's see how to forward all the connections through the cable. Note that the method we are going to see works for all the connections seen until now. In order to forward the communications through the cable, we need to download a tool named iTunnel. iTunnel can be downloaded at the following address, and it's also free and available for Windows and Mac OS X. Once we download and extract its contents, we have two files. The one called ITNL is the binary that we are going to run. So let's open a terminal and move in this folder. The tool is very simple to use. We just need to set the local port where we are going to connect and the remote port of the device. For example, since VNC works on port 5900, we can run the following command. ITNL --L port 5000, where L port tells the tool we are going to define the local port on our system that will be forwarded through the cable. Then let's set the remote port with the option --I port 5900. This tells the tool that the connection must be forwarded to the port 5900 of the device, which once again is the default port for VNC. Let's hit return and see what happens. Here we can see that port 5000 of our machine is now listening for a connection. Then we can see that the tool waits for a device to be connected through the cable. Since it's already attached, the tool finds it and establishes a connection. So let's validate that it is working. Let's now start VNC Viewer to see how to connect. This time we have to establish the connection to our local host address to the port 5000, and then the tool will forward the communications through the cable to port 5900 of the device. So let's insert the loopback address in here, followed by the local port set before. Of course, if we use 5900 as the local port, we don't even need to set it here, since it is the default port the VNC Viewer uses. So let's click Connect. As we can see in the terminal, a new connection has been established. Now, in the same way as before, let's insert the password set for the VNC server, and the connection has been established. Since it goes through the cable, it is much faster. Indeed, the quality of the image is better, and the interaction is much smoother. We can do the same thing for SSH or SFTP connections. We just need to set different ports. For example, let's see how to start a SSH connection through iTunnel. Let's write a command similar to the previous one, but let's set the local port to 5001 and the remote port to 22. Now in the new terminal, let's use SSH command to establish the connection. Of course, we have to use the loopback address and the port 5001. As we can see, as soon as we hit return, the connection is established and we have to insert the SSH password. So now we have once again the SSH shell on the device, but this time the connection has been established through the cable. So as we've seen during this video, we can use several methods and tools to interact with an iOS device. We can browse its content using third-party software such as iFunbox. We can spawn a device shell through SSH. And we can also display the screen view on our Mac through VNC. As we will see later on, all these methods are very useful during our tests since we need to run commands directly on the iPhone or download and upload files to it. That concludes this training. Thanks for joining us.